about x squared plus y squared when we found x and y intercepts. We found those. We said it is a circle. But we want to go overall in general here for circles. Let me see you guys notes. All right, you don't need to get this down. I didn't leave room for this, but I just want you to take a look. Using the distance formula. Okay, obviously that's a circle. Okay, using the distance formula, how would we show the distance between those 2 points? Okay, well, you know the distance equals square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. You're given 2 points. All right, well, the 2 points we're given are hk and xy. And we don't know their coordinates. We're just going to use it in general. All right, so plug that into the distance formula. What's it going to look like? Okay, so d equals square root. All right, x2 minus x1. So I'm going to take x minus h quantity squared plus y minus k quantity squared for that. Well, that distance is the same as what for the circle? That would be equivalent to its radius. So I could take d and I'm going to replace it with an r. So the radius is equal to the square root of x minus h squared plus y minus k squared. All right, last thing we're going to do for this one is what happens if I square both sides? It gets rid of what? Gets rid of the radical. So r squared equals x minus h squared plus y minus k squared. Well, will the distance between any point on this circle and the center always be the same? Yeah, because it's the radius. This is essentially our equation for a circle. Okay, what does hk represent? Center, and xy is any point on it. So this is called the center radius form of the equation of a circle. All right, now that is on your guided notes. So the center radius form equation of a circle is x minus h squared plus y minus k squared equals r squared. R is your radius, center is hk. And so that's essentially it. And hopefully it makes sense because we build it up through the distance formula. It's just using the distance formula with any point on the circle and your center. All right, now let's apply it a little bit. Oops, I didn't want that up there yet. Okay, find the center radius form of the circle with center -2, 4, and radius 3. All right, all we got to do is substitute in. Okay, so x minus h squared plus y minus k squared equals r squared. All right, here's what we're going to plug in for. You're going to plug in for your center. You're going to plug in for your radius. You typically have an x and y when you're finished. Okay, so the center is -2, 4. So it's going to be x minus -2, which becomes a plus. So it's going to be x plus 2 quantity squared plus y minus 4 squared equals 3 squared, which is 9. So if it comes out to a nice number, make it a 9. All right, that's it. That equation will give us a circle. Now, on some of the homework, it tells you to graph it. I'm not so concerned about graphing it. You need to know how, so I just want to at least do a rough sketch of a couple of them, making sure you're fine, but you should be okay. The center is -2, 4. All right, if you're going to graph it, you know the radius is 3, right? So go 3 units to the right, 3 units to the left, 3 units up, 3 units down to kind of give you some points to work with. And then 1, 2, 3. And so you should be able to, oh, that's not a great circle. A little off. But that's all you got to do. Okay, once you get the center and once you got the radius. Okay. All right, now what if it's giving you backwards? I give you the equation. It says identify the center and radius for x minus 5 quantity squared plus y plus 8 quantity squared equals 50. All right, well, what's your center? All right, if it's in, it's kind of always the opposite. If it's a minus and a plus, it's actually going to be positive 5, negative 8 is my center. Okay, because it's always minus a negative gives you the plus. Okay. What's your radius? Now you got to be careful here. R squared equals 50. R equals, don't cut it in half. You got to take the square root. It's going to be the square root of 50. Okay. So the radius is the square root of 50. If it simplifies, you can simplify. It just depends upon what they ask you. So square root of 50 is going to reduce to, or simplify to 5 square root of 2. Okay, for that. So there's your center, there's your radius. So they give you that. All you got to do is say 5, negative 8, radius is square root of 50. All right. Now, sorry, not always that easy. So is that one already written down there? Yes. All right, can you look at that and tell me the center? No, probably not. Can you tell me? You can't shoot. The radius is not 2, I'll tell you that, or square root of 2. All right, here's what we got to do. We got to make it look like these equations here in order to get the radius and get the center. How do we do that? We're going to have to complete the square. Completing the square comes up in different scenarios. This is another scenario where it comes up. So first thing you want to do is you want to group the x's together, group the y's together, and we're going to get the constant on the other side. So I'm going to write this as x squared minus 6x. Okay, I know what's going to happen, so I'm going to leave a spot here. And then I got plus y squared plus 10y. And I'm going to leave a spot here, and I'm going to move the negative 2 over to the other side and put a 2 in there. How do you create a quantity squared? You complete the square. Do the same rules we've done before. We're going to have to do it on 2 different cases. Now, when you complete the square, you are always adding that third piece. And if I add something to the left, I got to add it to the right. Okay, so I got to keep my equation balanced. All right, our rules don't change. You take half of the x term and then you square it. Okay, negative 6 divided in half is negative 3. Negative 3 squared is 9. So this goes in as a 9. Well, if I put in a 9 on the left-hand side, I got to put in a 9 on the right-hand side. Well, what's going to be my other number over there that I need to add in? Half of 10 is 5. What do we do with that? Square it. What's it give us? 25. So I take 10 divided by 2, which is 5. I square it. I get positive 25. So that goes here. That goes here. Now, these are like 2 separate problems. X squared minus 6x plus 9. What does that factor into? Better factor into a quantity squared. It's going to be x minus 3 times x minus 3. Now, this is the only time I'm going to write it out twice. Usually I'm just going to jump to where it's quantity squared. But this is what it's going to become. Plus, this is going to be y plus 5 times y plus 5 equals, all right, what does this add up to over here? 36. So now this is x minus 3 quantity squared plus y plus 5 quantity squared equals 36. All right, now what's your center? Now it's a piece of cake. Center would be positive 3, negative 5, and your radius is 6. Center, positive 3, negative 5. Radius is square root of 36, which is just 6. Okay. So if they don't give it to you in the nice form, which is what the center radius form, you got to make it center radius form. Okay, you got to do that. All right, same idea. Same idea. Identify the center and radius for the following. 2x squared plus 2y squared plus 8y minus 2 equals 0. All right, one thing we got to watch right here. You cannot complete the square if there's a coefficient in front of the x squared or the y squared. This will only be a circle if these are the same two coefficients. Like if this was a 2 and that was a 3, it wouldn't be a circle. All right, we'll get into what it would be later, but they have to be the same. We cannot have those. So if you do have a coefficient in front, divide everything by that coefficient. Technically, I'm even dividing that 0, but it'll just give me 0. So I get x squared plus y squared plus 8y. Nope, that would be 4y. Minus 1 equals 0. All right, slightly different because there's no x term, right? Is there? That's okay. That's actually easier. I do want to get the constant on the other side. So I'm going to move the 1 over. I will not have to complete the square on the x squared. It will just stay as it is. So it'll just be x squared plus y squared plus 4y. I will have to complete the square here, move the negative 1 over, make it positive 1, and whatever I put here, I have to put on the other side. Complete your square there. Y squared plus 4y plus, take half of 4, which is 2, square gives us, what'd you say? 5? Oh, over when you're done over there, but this will be a 4 right here. Because you're going to take half of 4, which is 2. 2 squared is 4, and so that gives me a 4. All right, what do I do with just the x squared? Because we say we want to be a quantity squared. Well, that's going to be the same as x minus 0 squared. So really, that's going to be a 0, which you can just leave as x squared. Okay, I wouldn't change it. Just leave it. So that's going to be x squared plus, this is going to be y plus 2 squared equals 5. Center. All right, center. If it's just an x squared, it's going to be a 0 as that coordinate. This is going to be a negative 2. So it's going to be 0, comma, negative 2. Radius is going to equal square root of 5, radical 5. Okay. The problem we did in class yesterday, it was x squared plus y squared equals 9. All right, if you have that, what's your center? I don't have to do anything. Center's what? 0, 0. Center 0, 0. What's your radius? 3. And so remember we graphed it yesterday, and the center was 0, 0. Radius is 3. So if you don't have that extra x or y term, then your center is going to be 0, 0. So if you just have x squared, that part is 0. Okay, for that. So that's how you take something that's not in a nice form, put it in that center radius form, find your center, find your radius. All right, I want to see what you come up with. Here's that last one. Now, I got the picture there if you need it. It says, find the center radius form of the circle with center 4, 2, passing through the point 0, negative 3. So this is the only way this could look. Here's my center. Here's the point 0, negative 3. Passing through means that's what it hits it. All right, see what you can come up with. This is one of those problems where we haven't done one specifically like it, but you have all the information to figure this out. There's a couple of different ways you can get it. All right, so at least think through it. If you get stuck, no big deal. not. It doesn't go to left or right or up or down. Because if it did that, then you would say the radius of 3 you would have to hit. Like there, and there. Okay. Okay, now to answer the question, some of you are starting to get it, and I will go through it for everybody else here. Today, find the center radius form of the circle. I want the equation. The equation is going to be x minus 4 squared plus y minus 2 squared equals 41. Okay, that's what it's going to be. Now, where'd that 41 come from? A couple different ways you can get it. You know the center. You know the center, so you should know this. It's got to be x minus 4 squared plus y minus 2 squared. It's got to be that. You can't change it. We don't know the radius. Okay. The radius is the length between the center and any point on the circle. One way you can find this is you can find the distance between 4, 2 and 0, negative 3. Just using the distance formula. So distance equals square root 0 minus 4 quantity squared plus negative 3 minus 2 quantity squared. That gives me negative 4 squared is 16, negative 5 squared is 25, and I get distance equals square root of 41, which would be your radius. So my radius equals square root of 41. Well, remember, you got a square. That's why it's positive 41 over there when we're done. You might have used the formula, plugged it in, and came up with 41 as well. There's different ways you can get that. But the square root of 41 is your distance. When you square it, you get back 41. But make sure that you write that answer in that correct form. Okay. As part of the homework, they'll talk about a circle that touches either the x-axis or y-axis. I want to at least explain that. So if I got a circle, let's say the center is negative 6, 4, negative 6, 3. There's the center, and it touches the x-axis. Well, what does that mean? Okay, it means that the edge of the circle, okay, would just touch that axis like that. Okay, so that's what it means when it touches the x-axis. If it touches the y-axis, it just hits it the one time. It doesn't go through it twice, just hits it once. So can you give me the radius from there? The radius for that one would just be 3. All right, so that's what it means when it touches the x-axis or it touches the y-axis. So that comes up in the homework. All right, flip it over on the back. I want to put a couple things in the back. I know there's nothing on there this time. All right, this comes up. You've had this before, but I want to hit it again just so it's a reminder. Slope-intercept form of an equation. Okay, going through there, writing equation of lines. It's something that you should be pretty good at, but sometimes you just need a little bit of a refresher. So I want to hit that real quick here. Slope-intercept form. That is y equals mx plus b. Y equals mx plus b. It says, write the equation slope-intercept form for the following. A line that passes through 2, negative 5 and has a slope of m equals 3/2. Okay. Now, the way I'm going to teach it is the way that you typically use in AP Calc and Calc is when you write equations of lines, they're typically going to go what's called point slope form. I'm going to use y minus y1 equals m times x minus x1 to do my work. And then I'm just going to get y by itself. Okay, this is point slope form. You've seen it. You've used it in geometry. You probably used it in Algebra 2 a little bit, but some people automatically go to this case here. I'm going to do this because sometimes you can leave your answer in that form. So I'm going to do everything in that form when I'm using equations of lines. All right, how do I find the point that passes through 2, -5, and has a slope of 3/2? The x1, y1 gets replaced by the points. The m is your slope, so this becomes y minus -5, which is y plus 5. My slope is 3/2, and then x minus 2 would be this case here. Now, since the direction said put it in slope-intercept form, I'm going to distribute the 3/2, and then I'm going to subtract the 5, and I am going to get y by itself. Sometimes you can just leave it like that, depending upon the case. Sometimes you can leave it like that. Sometimes you got to take it further. We're going to take this one further. I get y plus 5 equals 3/2 x minus 3. Subtract 5. Subtract 5. Y equals 3/2 x minus 8. So there's your slope-intercept form. But I'm going to start all my working point slope form. All my working point slope form. Okay. So if I got a point, I got a slope, I substitute it in, I get the equation of the line. All right, I just want the equation of the line that goes through those 2 points. All right, so it goes through -3, 5, and 1, -7. Well, the last one I gave you a point, and I gave you the slope. This one I gave you 2 points. What didn't I give you? I didn't give you the slope. Can we figure out the slope? Yeah, use your old slope formula. So we're going to have to find the slope. So m equals, remember the slope formula is y2 minus y1 over x2 minus x1. And so that's going to be I'm going to do -7 minus 5. 1 minus -3 becomes 1 plus 3. I get -12 over 4, -3. I'm going to go to y minus y1 equals m times x minus x1. All right, which point do I need to use? Doesn't matter. Pick either point. If I got a point where both are positive coordinates, I'm going to use that. But one's positive, one's negative, so it really doesn't matter for this case. My m is -3. I'm just going to pick the second point, 1, -7. So this becomes y minus -7, which becomes y plus 7. My m is -3, x minus 1. And then I'm just going to finish this off and get y by itself. So I get y plus 7 equals -3x plus 3. Subtract 7. Y equals -3x minus 4. If you really want to double check and make sure you're right, you plug in the other point and make sure it works. So if I plug in -3 for x, -3 times -3 is 9. 9 minus 4 gives me 5. If it works for that one. If you made a mistake, you still plug in that original point, it'll still work. So you always plug in that other point. So we found equations of lines given a point and a slope, given 2 points. Now you also deal with parallel and perpendicular. You remember parallel lines. What's true about their slopes? They're the same. What about perpendicular? All right, opposite reciprocals. So let's just take a real quick look here. So recall, parallel lines have the same slope. Perpendicular lines have opposite reciprocal or negative reciprocal slopes, however you want to word that. And what that means is if you have a slope of 2/5, the perpendicular line would be -5/2. If you have a slope of 1/4, perpendicular line would be -4 over 1 or -4. So you flip the fraction, one's positive, one's negative. Parallel lines always have the same slope. All right, we want the equation of the line perpendicular to y equals 3x minus 4, passing through the point 9, -4. Okay. I'm going to use y minus y1 equals m times x minus x1. All right, what slope do I use since I'm dealing with a perpendicular line? I don't use a slope of 3, but I use a slope of -1/3. So I want to use m equals -1/3. and it passes through this line 9, -4. And so I just substitute in here. So y minus -4 is y plus 4. -1/3 x minus 9. And so I'm just going to end up getting y by itself equals -1/3 x. Negative times a negative is positive 3, and then subtract 4. And you get y equals -1/3 x minus 1. Okay, for that. So equations of lines. All right, main thing on the homework is circles. Okay, you actually will not see the line part. That's something that we'll do here as we go through the chapter. All right, page 196. And I got here, you do not have to graph the 79 to 87. It says something about graphing. You do not need to worry about that. And then only do part A for 90 and 91, because I think part B asks you to find x and y intercepts. You don't need to do that. Okay. At this point. All right, we do have a late start tomorrow, so we will have a short period.